Project 6-2 wants you to have CentOS 7 and Ubuntu running. They want you to view the installation log files for each and compare the two operating systems. I'll just go over one of the steps. Step 3 on Project 6-2. You should be able to do the rest of the lab on your own. So this one we're going to use egrep. Remember, that's for extended grep. And we're wanting to look at errors and warnings. So we put in quotation marks and parentheses the word error, the pipe symbol, warn. Pipe symbol means or, so we're going to look at error or WARN. So in the parentheses, in the quotes, and looking under the var log installer syslog file. So that would be for Ubuntu. So we hit enter, and it brings up anything that has a warning or an error in the extremely long log file. So that's a good way to see if there's anything that you may need to look at closer after installing and setting up a system. None of these are major errors that we need to worry with. I just wanted you to see that you can do that after an install. So complete Project 6.2 on your own. Once that's done, we'll move on to Project 6.3. So in 6.3, we talk about ZFS. Probably means zettabyte file system, since the file system can be as big as 256 zettabytes in size, which is an astronomical number. We need to log in to the Ubuntu system as user1 and secret as the password, and then do our sudo su- to get to the root account. The ZFS infrastructure is not installed into Ubuntu by default, so we'll need to download it. The ZFS is a combination file system and logical volume management. So to install it on Ubuntu, we use apt-get, which is very similar to yum in Red Hat or CentOS. So same syntax, only the command name is different. So we get apt-get and put -y to answer yes to any questions. Then we're going to put install. I'm going to type in build essential space zlib 1g-dev uuid-dev vim-nox, and then python software properties. We'll hit enter. If you get an error, you probably typed something wrong. So double check your spelling. We'll download and install these systems. When you're wanting to set up something like this that you have to install off the internet, you typically go to Google and browse how to set up ZFS on an Ubuntu system, and it will let you know exactly what to install. That way you don't have to try to guess which packages are required to grab for ZFS or anything else that you might want to put on a Linux system. Google is probably one of your best friends. After the installation is done, it tells us that we need to add a repository. A repository is a server that has installation packages on it. So step 3, we're going to add something to the apt program. So it's add-apt -repository. And then there's a PPA :ZFS -native /stable. So it's going to add this extra server. It has all the packages, and stable means all the tested packages. Make sure that there's no known bugs in them. And then we will update and install some utilities for ZFS after this is added. Don't forget to hit enter to continue. So once that is added, now we will do an apt-get update. This contacts the server and it downloads a file that contains a list of all the programs that are housed on this server. Now that the server knows what is on the remote site, we can type in apt-get -y install Ubuntu ZFS. You'll now install it and all the other packages that Ubuntu ZFS requires. After an extended amount of time, upwards of 20 to 30 minutes, the modules for your kernel will be built and installed into the system. And one of the reasons that we had to install this separate is because the license is not under the GNU license for ZFS. It was created by Sun Microsystems, so it has to be installed separately. It cannot be included with a normal Linux distribution. Now would probably be a good time to take a snapshot of your virtual machine. We'll start editing configuration files. So the drivers are installed, but the kernel is not set to load them automatically yet. So go ahead and take your snapshot. And once that is done, we need to edit the modules, or basically it's the driver file for Linux. So vi space /etc/modules. There should be 2 modules loaded, LP and RTC. We'll go down to the end, hit I, insert, move the cursor to the end of the line at the end of the RTC, hit enter to start a new line, and enter the drivers for the ZFS as in the document. Double check for spelling errors, transposition of letters. Once that's done, hit escape, :WQ. And then we're going to update the initial RAM disk, which is a file that includes all the drivers that need to be loaded into memory before Linux is fully installed into the system. So the grub bootloader loads this file first for accessing file systems to be able to load the rest of the operating system. This too will take a little bit of time to build the file that includes all the drivers. Once it is done, you need to reboot the system so that it comes up with those drivers in memory. Once the system comes back up, we'll log back in as user 1 in secret. We'll type our sudo su- and the secret password again to get root privileges. Now the ZFS is a logical volume manager and file system all rolled into one. So we typically would use several hard disks and link them together, similar to the way I described logical volume management in the previous chapter. However, the installation of Ubuntu had us only do a 20 gig disk and take up all of the space. So we're going to use a command to create some empty files, very similar to the way that VirtualBox created empty files for us to install Ubuntu or CentOS into in your operating system. So we're going to use the dd command, and we're going to use a device of 0, meaning it puts out all zeros if you read it. So IF is input file, and then we have a space OF, output file, is equal to /disk1, bytes per sector, 1024K, and we're going to create 128 of those. We're going to do this 4 times. I'm going to use my up arrow key and change disk 1 to disk 2, and then disk 2 to disk 3, and disk 3 to disk 4. So that should create about that should create 434 megabyte files. There's nothing but zeros in it. These can be used to simulate a hard disk for this lab. Let's go ahead and do a zpool create web store or web storage using disk 1. And then zpool list shows us we have a volume called web storage, and it is 112 megabytes in size. So it's using just that one file. There's no fault tolerance or anything, using just this one. It wants us to see if we can copy a file into web storage. And then look inside of web storage and see if the file exists. It does. Notice there's no lost and found directory that is not created with this type of file system. Only the Linux ext versions 2, 3, and 4 will create your lost and found directory. So I believe you're at a point to take a screenshot at this point. And then we're going to destroy the web storage, deleting that. Now we'll create another one in step 11, except we're going to mirror 2 disks together, disk 1 and disk 2. So that means that any data recorded into disk 1 will also be recorded into disk 2. So if they were physical disks and one of them failed, the other would still be there and still have all of the data and still be accessible. So you should be able to finish the rest of this on your own. Just to show you the very end of 6.3, when you want to take your screenshot and you do the ZFS get all web storage site 1, you'll have to hold down your shift key on the keyboard and hit page up until you get back up towards the top where you can see your command that you typed. You can also see that the quota is set to 10 gigabytes on the screen. Once that's done, do your screenshot and submit, and then watch the next video for Project 6-4 on recovering a file system.